pressure of the stuff trying to push out while gravitation is trying to collapse things, which has to do with being ionized and hot and crazy, like the early universe, is what was causing the oscillations or the sound waves, literally, in that early universe, hot dense plasma. But once things went through recombination phase of the universe, evolution, and neutral gas was made, neutral hydrogen was made, and there was not as much ionization of the matter, then the sound waves kind of froze in place. Photons decoupled from matter and streamed away, and the pressure that had been driving the oscillations dropped. The traces of these primordial sound waves were left imprinted on the matter. The regions that happened to be at maximum compression or rarefaction at the moment of decoupling became slightly denser or thinner than average. Those slight density enhancements are recorded in the CMB as the pattern of hotter compressed and colder rarefied spots that we observe across the sky even today. So these compressions and rarefactions and spots of compression and rarefaction because of these sound waves that froze into place are still something that we can observe across the sky. In other words, the CMB spot pattern is a direct record of the acoustic vibrations in the early universe. So looking at these types of oscillations now and kind of, working it back to what happened back then is very interesting and provides information as to what was going on in the early universe, which is still imprinted in the CMB. So you can understand that among other reasons why the CMB is so important, it even has this type of information coded into it, okay? Because these acoustic ripples were frozen into the matter distribution as well, they also left a subtle mark on how galaxies later clustered. Because remember, the CMB's fluctuations and overdensities, fluctuations from the smooth CMB and regions of overdensity is why we eventually got galaxies. So if you've got information about these overdensities in the form of these acoustic oscillations that are frozen into the CMB, then in a way you also get to know how galaxies started to form, because it's those overdensities are the same reason why we have galaxies eventually, right? So as the universe expanded over billions of years, gravity amplified the initial high density ripples, so the initial high density ripples into galaxies and galaxy clusters. So over time, as the universe continued to evolve, continued to expand, these initial high density or over density ripples later became galaxies and galaxy clusters, while low density regions became vast cosmic voids. So the cosmos is both huge expanses of empty space, which turns out to be not so empty in the particle physics standpoint, but also galaxies and galaxy clusters. So both of these came from these acoustic oscillation CMB stuff, which is really, really interesting, right? It's like really literally primordial stuff that we're talking about now that we can measure in the CMB. Slightly more galaxies formed along the ancient sound wave peaks. So can you imagine? These are ancient sound waves that we can still see coded in there. And these ancient, like literally ancient, because these are from the early universe. And these ancient sound wave peaks, those peaks is around which we get slightly more galaxies. Imagine concentric shells of galaxies tracing where the waves once pushed matter outward. We can still detect this pattern today. For any given galaxy, there's a slightly higher probability of finding another galaxy about 500 million light years away than at other distances. You should check that, by the way. I'll check the source, okay? These echoes of primordial sound in the present day galaxy distribution are known